for something to do. This is your first few minutes getting going with Clojure, especially if you haven't used a Lisp-like language before. Right. Clojure. So, came out in 2007 by Rich Hickey because he couldn't find something that did what he wanted, so he wrote it. And these are some of the kind of headline points of why Clojure, why bother to write it. One, because you like Lisp. So, dynamic and predominantly functional. It runs on the JVM, which was probably a biggie for getting it actually widely used. But there's a subset that now runs on JavaScript for the browser, or Node, sorry, and also on the CLR. So one of his big points was he wanted something that was good for multi-threaded programming. So an emphasis, I mean, similar to other functional languages, on immutability, use of value types. But also, since it's relatively young, we have software transactional memory, which sounds great and turns out to be pretty much what you'd expect from a database, I suppose. Descending from Lisp, it's dynamic. Anything you can do at compile time, you can do at runtime. And part of what you can do with that is programs that write programs or programs that parse programs. And Lisp helps you to do that because the code of a Lisp program looks pretty much the same as the data structure that Lisp understands. And then at the bottom, again, being a relatively young functional programming language, he's kind of picked up on all the buzzwords he thought were good. So polymorphism I would have associated with OO, but Clojure does it. What else? Agents probably nicked from Erlang. Optional, it can be completely weakly typed, but you have the option of using type hinting. So, first thing to know, it looks like Lisp. So for those of you who haven't worked with Lisp before, fairly easy to read. There is only one structure in Lisp, kind of, and that's a list. So the way you read it as code is, the first thing is the function, and everything else is the arguments. So namespace fizzbuzz.core. Define function fizzbuzz takes an I, and condition is like an if else, if else, if else. So if it divides by 15, you've got to say fizzbuzz. If it divides by 3 or 5, fizz or buzz. Otherwise, just return what you've got. Define function fizzbuzz as far as n. Take the first n of the following, and MapReduce. Popular in functional languages. So map takes, right, it runs backwards. Let's start at the right hand side. Iterate inc1 says iterate forever, applying the function increment, which is add1, starting with a seed value of 1. So this little fragment of code, if you run it in a REPL, will generate the set of positive integers, which means it will run forever. So one of the features of Lisp and several other functional languages is that you can handle infinite data structures because you do lazy evaluation, which means you only look at the beginning of the list and you ignore the fact that the rest of it is infinite. So take this infinite list, and for each element of the infinite list, apply fizzbuzz at. So this effectively maps 1, 2, 3, 4, 5 into 1, 2, fizz, 4, buzz, etc. Yeah. So that's what Clojure, and for that matter, Lisp and related languages look like. Is that reasonably readable? Understand? Yeah. Yes. That's what I told you. Try Clojure, works in the browser, you can try a bit of Clojure. So, the selling points of Clojure then, emphasis on immutability. This bit of code doesn't really show you much except for the fact there is no way to change the value of a variable, and indeed there aren't really variables. So if you define a function that you want it to mutate something, it takes a parameter x, it tries to add the word lots onto the end of x, and it tries to assign that to x. In fact, this will not change the value of x. It will, I mean, you can reproduce this in other languages too. So start off with let x be 1, 2, 3, try to mutate it, and the result is x is still 1, 2, 3. So part of the philosophy, in OO, you try and you hide state inside, you encapsulate it inside an object. Rich Hickey's view was that state surely is a series of immutable values, so you can't actually change it. So, second thing, metaprogramming and macros. So, a simple example of metaprogramming looks just like a function. Define macro hello, and it will put the words hello in front of it. The point is that the macros extend the compiler effectively, so that if your language doesn't have features that you would like it to have, you can define them. So some languages have an unless keyword, Clojure doesn't. You could define it as being, define unless to be, you turn it into if not the condition, then the forms. So unless age is less than 18, you're allowed to apply to join with your name and email. That will turn it into if your age is not less than 18, then yeah. So macros in Lisp and Clojure are not the kind of weedy macros you have in some languages, but they allow you to create new language constructs. So say in C# Java, lambdas come in or some great new programming language feature, you have to wait for the new version of the JVM or of the CLR to come out before you can have it. In a language that does this, you can write it yourself, which is great and obviously leaves you plenty of scope for making a mess of things. So, software transactional memory, a great phrase. But very like what a database does. So I said there are emphasis on the mutability and value types. You can define something to be a mutable reference by using the def and the ref keywords, and you can then assign it a new value. However, if you just try to set mutable entity new value, it will throw an illegal at state exception because you have to do it inside a transaction, which is just wrap it in a do thing. But the point, of course, is that it actually does do transactions. So if you have a multi-threaded program, if you have multiple threads trying to change the same thing, each thread starts the transaction, tries to do its changes, commits at the end, discovers possibly that another thread has changed the values it was relying on. The thread will then go back to the beginning and try again. So in databases, it's the equivalent of snapshot transaction isolation. Each thread inside a transaction sees a snapshot of the state at the point it started the transaction. So again, providing features for concurrent programming. I do OO for my living, mostly in C#. So learning Clojure, I guess, has left me thinking, well, what can I learn about OO? These are some of the comments that Rich Hickey explained. Why did he do Clojure? And these are some of them are, I guess, ideas that I've picked up from it. Mutable shared state. I read that quote just at the point I'd spent about 3 weeks working on less than 100 lines of code, but it was a web page and it was impossible to work out what it was doing unless you knew precisely what the user had been doing leading up to that point, and it was a mess of session state. So that kind of hit home for me. The third comment I find interesting: OO was born as simulation and it's now used for everything, even when it's not appropriate. A fair comment, I think. That's the second to last one. The first time you try and write a program that doesn't mutate things but just has immutable values, it really feels quite hard. But eventually it turns out pretty much everything you would do with normal procedural code. You can do it with values, and actually you don't need entities reference nearly as much as you think you do. So you are. Clojure. Thank you. Any questions?